So there's liquid will be flowing here. So the liquid will flow here, and these are the plates. It's telling the basic principle of magneto-hydrodynamic generator used for generating parallel plate capacitor. So there's a plate. I'll write it. Huh? There'll be other plate, and the connections will be done like this. And there's an external magnetic field. This is some sort of like a, you can say like a tube which will provide support for the flow of liquid. So here I could have done like this. Means it's a continuous, there'll be tube will be there. Yeah, now get into the problem. With a constant velocity V. So like, can you show V? There's a V. Flowing liquid. I think somehow if you have to struggle to understand the situation. Once you get that, problem is very easy. You can sail through the problem very, very comfortably. Conducting liquid. So what you can do with that? Very sad to say that in India, there is no such research on these things, very late. Small, even African countries, they have come forward in using all these things. In India, it became very late. Maybe in the 2000, we have started. Long back, 1970s, what happened? The African countries also started this one. Okay, the parallel plate capacitor. So I'll begin like this. So this is the plates of capacitors. So this is what that particular. All these are experimental based questions, application based numericals, not like something numerical. All these are some based on some real applications. Now we have, okay, there's a circuit. Okay, resistor R is here, no? Yeah, we can save some place for us. Yeah, no. So this is R, you take it. Now, look at the magnetic field. Magnetic field shall we put here out of the plane, B bar. Just I'll put only one dot. Make it a plane diagram. It'll be easier. And how the velocity, let's assume a positive charge moving like this. Now this positive charge is moving here. In what direction? It will experience a magnetic force. B bar, it will be upward. Then because of this, a deposition of positive charge will start occurs. Then the lower part of this liquid at other plate, the liquid will acquire negative charge. Then in what direction there'll be induced electric field in this direction, EI. Don't say induced electric field, or else write it E only, due to drifting of electrons. So now finally, what we can write, FB equal to QE. FB is what? QVB is equal to, this is QE. And because of this, there'll be a potential difference setup. Let's assume that what is V naught is PD across capacitor. No, so this will be, we can write it as VB. This will become, I'll write it as E is uniform. So we'll write it V naught. So V naught equal to BVD. Keep it here. Will there be any flow of current? The flow of current. So what is I is equal to now? I is equal to V naught by R, which is equal to BVD by R. Is it only that much or any other thing is there? You try to read the question carefully. Liquid of electrical conductivity. And electrical conductivity of the liquid is, I think some symbol missing. I'll bring sigma. The liquid flows between the plates with a constant velocity. So even the liquid will also offer some resistance. So therefore, this should be the resistance, external resistance R plus that of the liquid. But we don't know resistance of that liquid. Anybody? Area of each plate is A. Distance between the plates is D. So what is the D? This is the D. This is area A. So therefore, this will become conductivity. So this will become A by sigma D. From where we know resistance of liquid should be equal to rho area rho L, no? I think rho D, this will become. So rho D by A. So this will become D by sigma A because we know rho equal to 1 by sigma. Resistivity is reciprocal of conductivity. Substitute that one here. So this is what our expression will be. This is a current I, which is equal to BVD sigma A R sigma A plus D. Now what shall I do after this? It's asking the how much power will it dissipate? I think it's quite simple, no? Power dissipated across the resistor equal to I square R. I'll square this, I'll substitute, I'll go the answer. Okay, last question. From where this power come? Anybody answers? I want students to really answer this. From where this power will come? Yeah, Rudransh, correct. Kinetic energy of the liquid. So therefore, some external agent has to do work, no? To maintain the velocity of the liquid. Yes, yeah. Everyone, Rudransh, Asita, Manideep. Okay, yeah, fine. So here, the work done by external agent to maintain the speed of the liquid constant, that work is what converted into power. So instead of this resistor, shall I put here a storing battery? It will start storing energy. So what we have to do? Just make the water to flow through this pipe is enough. Are you getting? No, there's a way of generating electricity now. It is widely used in Western countries now. Water will flow. Where water will flow? In the rivers, canals, even where the drainage water also will flow, no? So what to do for that? You have to just make it a conducting liquid. Of course, river water, we can't do anything. The water is also having conductivity. So that is enough. What is a good conductor of electricity? I think everyone knows. So what shall I do? If a water is flowing through a canal, okay, just bring this setup. You have to bring that external magnetic field. Of course, Earth's magnetic field is there, but is of very low value. So some of you can bring external magnetic field, problem solved. So where is water is flowing in the drainage, canals? Okay, rivers we can't construct, but at least the drainage we can construct. No, the Western countries started exploring the energy from that also. The drainage water will flow naturally. They're using it. All these are, you can say, like a electromagnetic induction. No, the chapter is such a beautiful, like wide applications. Of course, we are not that strong in terms of research in India, but in Western countries, there's a long back 1970s. This was started implementing in the drainages. Water flows in a drainage, no, from like a flowing drainage water. From that, they are generating electricity. Just imagine, we are unable to construct drainages properly. Forget about generating electricity. The use of technology. Okay, I think just squaring it, nothing to do. Just square it, this one. So what is the reason I should give? The work done by external agent in maintaining speed of liquid constant is converted as rate of work done. We'll write it. The rate of work done exchanged in maintaining speed of liquid constant is converted as power, electric power dissipated in across resistor R. Very, very useful application. This is one of the, you can say like a more creative, the best applications. So you do one thing. Are we using this in India? Yes. From I think 2008, we started using this one. We imported technology from the abroad and we started using. You go for lift irrigation. The lift irrigation, this is what we are using. So what we do in the lift irrigation, I'll lift the water to certain height, I'll make it to flow. When the water starts flowing, here I'll take a rechargeable cells. Here the electrical energy, this energy again will be utilized to lift the water. And this water open, which is, I'll just lift the water, I'll make it to flow here. There's a water, there's a lake. So here I'll construct a something. So now there'll be I'll make the water to flow down. From a pump, I lift it. Then when this flowing water down, what it does, in turn, it will generate electricity. This electricity, what will happen, will be utilized for what? Again, to lift the water. And this water, what happen? I'm going to pump it. So usually it happens like this, what happen? We can go for the lift irrigations. Okay, do visit. We have plenty of lift irrigations in Telangana where we are using this one. The lift irrigations are very, very, very important part of the modern agriculture. So if you are interested, you can do a lot of good research, everything. When you become